Bismillahirrahmanirrahim. We are the students of Sakkar Ayub University in Electrical Engineering Department. We have made soccer robot team under the supervision of Dr. Engineer Fahim Akhtar Chachad and co-supervision of Farhan Ali Shah. I, Engineer Chanesarmar, along with my colleague Engineer Mohammad Musab and Engineer Safiullah Sumro. Our project outline of our project is, first of all, we will introduce our project, and secondly, we will tell about aims and objectives, literature review, 3D design, rules and regulations, 3D modeling and implementation, robot and parts assembly, PCB design and implementation, app design, final results, and feature plan. In introduction, in this project, we have designed the mobile football robots, I mean soccer robot. Every component of this project is indigenously designed and made by us. Soccer robot is controlled through mobile via Wi-Fi. Robot is having omni wheels to move any direction without turning its face. ESP32 module is our main controller. Mobile app is developed to control individual robots. Chassis of robot is designed in SolidWorks, fabricated through 3D printing and laser cutting of acrylic. Kicker is made to kick the ball and dribbler is made to hold the ball. Actually, we have four main aims and objectives of our project. First, design and implementation of kicker. Second, design and implementation of dribbler. Third, design and implementation of omni wheels. Fourth and last, controlling of robot using mobile via Wi-Fi. In literature review part, we have studied 4 literature reviews. In first, we have studied the paper of Biledin, in which he told the idea of using soccer game for promoting science and technology. He also told us the benefits of soccer robot. In Rekul Ra's paper, he guided us about coordination of kicker, coordination of dribbler, and also the coordination and direction. He also told the directions of robot, how to control the coordinate and direction of robot. In S. Hamid Raza Modes Kesai, he mentioned in his research paper, Robbo Cup is a global tournament that promotes robotics and associates fields like as image processing, control, and device design. Soccer is one of the topics covered in Robbo Cup tournaments. Actually, when we studied these literature reviews, we have motivated from these literature reviews that how we can make our good project.
In our final year project, we have total 3 members. I am Mohammad Musab, and we have divided our projects in 3 parts, which is my work is defined in these bullets, like 3D designing, 3D printing, laser cutting, robot assembling, work of omni wheels. And Safila did some circuit designing, ESP32 programming, PCB designing and implementation, mobile app designing and communication. And Mr. Chanesar did kicker implementation, equipment selection and purchasing, billing, thesis and equipment, and parts availability. We have the RoboCup organization has designed rules and regulations for soccer robot. Our robot lies in small size soccer robot rules. Basically, there are 3 kinds of robots: large robots, small size soccer robots, and fighting robots. Our robot lie in small size soccer robot rules. We have F180 rules in which 2 teams play with each other, and 6 robots carry each team. The field is 9 meter long and 6 meter wide, but our field is 4 meter wide and 6 meter long. Our project is basically 180 mm diameter according to the rules of RoboCup soccer organization, and 9.5 centimeter higher. The rules, according to the rules, we have 15 cent, not higher than 15 centimeter robot. Hardware and softwares. Basically, we use three softwares: SolidWorks, in which we design 3D printing, 3D model. I will show you further ahead. And Eagle software for PCB printing, MIT App Inventor for mobile application. In hardware, we use a 3D printer, which is available in our fab lab. Ultimaker is the company, and a laser cut machine, which is Epilogue, and which is also available in fab lab. Node MCU, ESP32 module, 12 volt 1500 mAh LiPo battery for motors control. For motors battery, this battery is used for motors, and 3.7 volt 100 mAh lithium ion battery is used for activation of node MCU ESP32. L29 3D motor drive is used for control of motor, and solenoid is used for kicker. This capacitor charging module is used also for kicker design, kicker circuitry. 12 volt DC motor, simplest DC motor is used in our wheels, which is geared DC motor. Ball is used in our project is 55 mm diameter. Here 3D modeling, I show you simplest 3D models we design in SolidWorks. Here is the wheel with motor, here is the kicker, and there is a base with 4 motors and kicker, and there is an output, a 3D design base as shown in this PPT. This is the design of a battery. I'll show you the video. This is the holder, and this is a 1500 mAh battery, and this is 3.7 volt battery. Here we design in 3D, and here is the hardware implementation of our design, 3D design. And this is designed in SolidWorks, as I mentioned above. And this is the 3D printed, and this is the assembly of the battery holder. This is dribbler and dribbler assembly. As I started the video, it contains motor, motor dribbler, dribbler's rubber, which hold the ball. This contain 2 gears, 2 different gears with different diameters, and this contain this contain bearing, and this is the total 3D design and its assembly. And this is the implementation of our dribbler. Here is the motor, here is the designed 3D designed gears and a rod and dribbler. Here is the kicker implemented in the chassis. Here we can see that the assembly, which is done in 3D in SolidWorks. This is the Omni wheel, which is designed in SolidWorks also. I can play the video. Basically, it contains 5 parts. One is the battery, one is the left 3D part, left Omni wheel part, one is the right Omni wheel part, one is the small wheels, and this is for holding the tire in motor. Here the size of the Omni wheel is 45 mm, and the small wheel is 7 mm in diameter, and this is 5 mm, which is hold it in for motor, holder for motors. And the 5th one is the rod, which hold the small tires. And this is the 3D implemented wheel, it as I can show you that the holder and the tire omni wheel is assembled. The small tires is also contain three parts. One is the laser cutted 5 mm diameter circular shape, and is upper is the bearing, and which is 7 mm, and the last one is for rubber. And this is implemented for the frictionless and for the more better grip in the ground. This is the motor assembly with the omni wheels. As I can play the video. These are the holders which holds the motor. And this is the assembly this is the assembly we done in hardware. This is the holders which contains a bullet of 22 mm with the nut which hold the motor and the omni wheel. This is our 3D assembly in SolidWorks, which we have done. It contains the upper part, which is a soccer robot completed assembly. This is omni wheels, a kicker, dribbler, and the first floor batteries as shown here. This is the 3D design capacitor charging module PCB with ESP32. Here we did transparent first floor. As we can see downward, there is a motor holder with omni wheels. Four motors here for omni wheel and one motor for dribbler. This all work is done by us, our team. Here is some snaps for laser cut, which we have done in epilogue as we discussed above. Laser cutting machine. Robot base, there is a robot base with the different holes of a kicker and a kicker holder. And for dribbler and motor holders, and for supporters for first floors. And there is a first floor. Basically, the base is 180 mm in diameter, and the first floor is 160 mm diameter. For this is done because the upper part can easily lie in the base. And this is the leather cutted motor holders, and this is these also designed in SolidWorks. And this is our omni wheels, which is laser cutted with the 5 mm laser cutting, and these upper are base first floors, and holders are 3 mm having 3 mm in depth acrylic sheet. Now it's done for my partner, Mr. Safiullah.
Coming to the circuitry. So in hardware parts, the components that we have used, ESP32, which is our main controller, IC L293D for motor controllers, motor drivers, transistors are used, relays circuit is used, and boost converter, capacitors, these all components are used. Now the advantage of using ESP32 instead of using instead of using Arduino is that the ESP32 has many input output pins which can control multiple motors, and and other thing is this circuit is ESP32 is very compact, and it has a built-in Wi-Fi function that is requirement of our project. So coming to the ESP32, it has 19 input output pins and one TX pin and RX pin. The TX pin used for debugging, and the RX pin is used for it is high when the booting is done, and one VP pin, which is the controlling pin, and power pins, ground and VCC. So we can power ESP 5 volt. Now coming to the IC L293D, it is basically 16 pin IC. One IC can drive 2 motors at a time. So in this is our 4 motors are controlled here and on breadboard for testing purpose, and 4 motor and 2 ICs are used for that. Now this is the coming to this solenoid. Here we used our here we made solenoid for kicker purpose. So we tested on multiple times, but due to less power, getting less force, we purchased solenoid and used in our kicker circuit. So this is the module, and we designed MIT app, which is this. So to, all the motor directions, kicker, dribbler are controlled by mobile app. The platform for designing this app is the MIT app. So after testing on the breadboard, after getting accurate results, we designed a PCB. So on PCB, this one is the schematics diagram, and for placing all the components used in the circuit, and this is the routing, and this is very compact circuit to save the cost, to make it economical. So this is very complex circuit, and after all, this is the 3D printing designing. Now after soldering the components, this is the final circuitry, and one boost converter is also is on this, which is not shown here, but it is also attached with this. 4 pins are used for that. So this is the complete circuit. Here relay is used. Relay is used for switching purpose, and these 2 transistors and resistors are used to get the 5 voltage. Those 5 voltage are controlled using ESP32. ESP32 basically it's a digital output pin, will give 3.3 volt, and we will using transistor circuit we can make 5 volt to energize the relay coil. Relay coil is only used for switching purpose. This is the capacitor, and the booster module, it is also used, which is not shown here, to boost the voltage from 12 voltage to 45 voltages. Now we can also get 75 voltage on variety on different ranges, but according to the capacitor rating, 50 volt capacitor is used, 1500 microfarad. So for that we have designed our boost converter on 45 voltages. This is the IC 16 pin IC relay. Now this is the shape of the robot that we run on the field multiple times, and this is the complete design that we design in the software, and this is the hardware design. In this shape we got our circuit. These are the apps. This one I've designed 2 screen app. The first screen app is this, and after logging and signing in, we can go to the second screen. And second screen we can get the we can insert IP address, and using that IP address we can control our robot. And this is the testing testing app. Here we have controlled our robot RPM, motor RPM. That on first of all we utilize our maximum speed of the motors, that is 464, and then we controlled up to 150 RPM. This is the field there where we designed, and this is the final testing. Here we also calculated our force, and here we drive Here all motor directions are controlled. Forward right, stop, forward left, backward right, right, and then left. These are the directions that we control, and we did 8 direction robots. Total directions are 8. And I forgot to describe the coding of ESP32 module. In coding, we derived 5 motors, 1 dribbler, and 1 kicker circuit. So using encoding, we control the speed of the motors, and also we did a coding for generating IP address. After burning the code on the ESP32 module, it gave us IP address, and then we used its hot Wi-Fi. Using we connected our ESP32 using hotspot, and after inserting IP address, we control the robot. This is the screenshot for our robot is basically funded through Ignite. So 4 total in our batch, 4 robots are funded, and our soccer robot is also funded. This is the screenshot. Making team up. So our purpose was to make a team of the robot. 3 robots we were given to design, but this time we have designed only 1 robot. So in future we will design this robot to autonomous. Thank you.